My name is Valentina Gonzalez.
I'm Maria Paula Salamanca.
And welcome to
The Biology Show.
So, continue with our chapter of genetics. Today we're going to be a scientist and get into the laboratory with some experimental practice like PCR
and gel electrophoresis. Now we are going to introduce you some procedures, uses in the real life, and other topics that you can like.
So let's get started. So Maria Paula, for what is useful PCR?
PCR is a polymerase chain reaction. It's a relatively simple experiment that you can use to focus into a segment of DNA and copy it billions of times over. It is used to diagnose diseases, bacteria, and viruses.
Oh, so interesting. So we're most focused in the medical science. Also, as gel electrophoresis.
So how about if you tell us more about gel electrophoresis?
Of course. So it is a method to separate DNA fragments. That fragments are leaded into lanes of blocks of agarose gel. A constant electric field is applied to the system that causes DNA fragments to separate. This is used to measure the length of different DNA chains and to identify plasmid viral DNA and particular segments of DNA.
That sounds too interesting, Valentina. So let's go to the laboratory. Let's go.
Starting point of the DNA is a source of genetic material such as hair or any skin, saliva. By moving your extracted DNA into a special PCR tube. PCR works by heating and coating the solution over and over, so PCR tubes are designed for heat distribution. For that, I need to drag the extracted DNA into the PCR tube. With a clean pipette, repeat the procedure with the primers. As well as the nucleotides and polymerase. Always having in mind you need a clean pipette. Drag the PCR tube, which is full of all the reactive substance, to the thermocycler. Then push start. Let's start in 95 degrees to separate the double helix of the target sequence. Then it downs until 50 to point the primers and increase to 72 to start with the DNA polymerase. To paste the nucleotides and complete the DNA copy. The cycle 1 is finished, and now it starts the 2 and until you have millions of copies of the target DNA.
The gel is a filter that sorts the DNA strands. It's like a sponge made of Gel-O with many small holes in it. We place DNA samples into holes at one end of the gel. Electrophoresis is how we push the DNA strands through the filter gel. By adding an electrical current, we can make the DNA move. Short strands move through the holes in the gel more quickly than the long strands. Staining the shorter groups of DNA makes them visible to the naked eye. So let's start with the gel electrophoresis laboratory. What you need to the laboratory is an agar rose, a flask, J-mold, buffer, a gel comb, microwave, and that's all. Now put a small amount of agarose into the flask. Add some liquid buffer to the flask. Then place a plastic wrap over the top of the flask to prevent the liquid from boiling over. Open the microwave and then place the flask containing the buffer and agarose. Pour the melted agarose mixture into the mold. Notice that the mold has tape on each end of the hole in the melted agarose. Place the comb into the gel on one end. Let the gel cool and solidify, and then carefully remove the comb, leaving the empty walls of the DNA. Now it's time to set up the electrophoresis box and pour the buffer into the electrophoresis box. Place the gel still in the mold into the electrophoresis box. We have removed the tape from the ends of the gel mold. Now we are ready to load the DNA sample into the gel. With a clean pipette tip, use the micropipetter to suck up some loading buffer, then add it to the DNA sample. Now we will use the micropipetter to transfer the DNA sample from the tube into the well of the gel. Hex the DNA sample from the pipette into the first well of the gel. Using a clean pipette tip, use the micropipetter to suck up some DNA size strand. Now, transfer the DNA size standard into the next empty well. Now turn on our electricity and plug the black cord from the electrophoresis box into the matching outlet on the power supply. Repelled by the negative charge, the DNA moves through the gel toward the positive charge at the other end. Short DNA strands move through the holes in the gel more quickly than long strands. Now drag the gel out of the mold and pull it into the DNA staining solution. It takes about half an hour to stain the DNA in the gel. Remove the gel from the staining solution and place it on the UV light box. Now we finish. You can determine the approximate lengths of the DNA strands in your sample, and that's all.